Good afternoon. My name is Kazmierzcak with Systems. And today I want to discuss some topics which I've been thinking about for a while. But as I've gone to a number of the presentations here this week, or yesterday, today, I realized that a number of folks have talked about peripheral pieces of the topic that's near and dear to my heart. Bob Thibodeau talked about bindings of TPM to self-encrypted drive. We had User talk about trust ecosystems for trust element, trusted execution environments. We've had Steve Hanna talk about security automation built on Trusted Network Connect. And even the panel this morning, there's the Internet of Things panel, and we talked about all the security implications and all those devices. And I realized that I kind of touched on a lot of those pieces, but the kind of the core central theme that's interesting to me is takes that and kind of extends it off in a little different direction. So hopefully this is entertaining and interesting, and maybe there's some details in here that might be valuable along the way. I'm going to be presenting some of my observations, and we're going to talk a little bit about what I view as the evolution of network trusted devices. And we'll talk a little bit about what services I think might be required to support those devices, whether they're existing or non-existing yet. So we'll talk a little bit about where I think we're going to go from here. All right, let's talk about Internet of Things. I made some observations. Obviously, you heard this morning a wonderful presentation about the Internet of Things and how these things are exploding everywhere. And there's huge security implications for some class of devices. The concept actually been around for a long time. Right? This is designed by, I guess this term was coined by Kevin Ashton in 1999. And ubiquitous computing's been around for a decade before that. It's a similar concept before that. So this isn't a new thing. It's just that the proliferation of devices has just exploded within the last half decade. But to me, the particular qualities, properties that are important are things like uniquely identifiable objects and sensors that can measure and report some attributes about whatever it is they're measuring, and having communication between those devices and other remote devices or machines or sensors. And so that combination of attributes to me becomes very central and is used over and over again. So this is a slide you actually saw this morning, probably, right? So I don't think we need to get into it. But the part that's important to me is not just the proliferation of devices, the massive number of devices, but it's that they're intercommunicating, right? It's not just a one-to-many, it's a many-to-many relationship between these devices. Sometimes it's yes, a whole bunch of simple sensors out in the grid that are all kind of going home. But in a lot of cases, that's not the case at all. There's complex relationships with these things. And it's those relationships and how to manage them and how to make sense of them that's of interest to me. Let's see. So I observed that there's a lot of small devices that are really underpowered, kind of unconstrained networks. They're not communicating all the time. They're sometimes available, sometimes they're not. There's really powerful devices that are sitting there as well. And sometimes powerful devices can act as gateways for the low-power devices, if they're available, if there's a binding between them. And it's those bindings that are kind of I want to explore a little bit. And throughout this process, it has some common themes, right? It's device identity. It's what capabilities do I have? How can I assert them? And how can someone that's remote make decisions based on those assertions? So there's this term called deperimeterization, and I think the important point here is that these devices are everywhere, and people who have devices want to connect with other devices that aren't under their control, right? If there's an operator who's got some devices, and there's all kinds of other devices they want to communicate with, but there's no way to know anything about them other than take somebody's word for it. And I think that over time, there's some concepts that are being expressed by some other groups. There's this group called Jericho Group, and they're part of the open group. And they've defined this term deprioritization. And what's important to me is the ability to have the flexibility to communicate from one device to another, independent of whether you're within your same trust domain or not. And specifically, to be able to cross trust domains from one domain to another, and to be able to make some trade-offs, some risk decisions based on those connections. So we'll start with identity. Right? I think that's core central to everything I'm going to talk about. And there are quite a few identities have been around for a very, very long time. Hardware identities have been around for a very, very long time. But there are a number of activities going on today, standards-based activities, that allow us to have interoperable identities. And sometimes there's software identities. There's some TCG has some specifications that define it. SCAP has common platform liberations. There's these structures called SWIDs, and we already do signing of objects all the time and comparison of signatures, the whole unified secure boot process, device drivers, etc. And we have reference measurements, so we've got an identity of something, and perhaps we'll have a reference measurement of what it's supposed to be. In a sense, the digital signature is one way of having a validation of that reference measurement. And there are other ways to develop reference measurements that are based on someone who's authoritative, whether local or remote. And even there are specifications that are kind of coming together to define common interoperable hardware-based device IDs. 802.1AR, AAA 802.1AR has been around for a while. There's certificates that have been defined in TCG for TPM keys to define device identity. And there are efforts that are in place to try to harmonize some of these things so that whether you're on a router or a switch or a TPM or an embedded TPM or a self-encrypting drive or something else, can we express device identity in some common way so that we can have systems that digest those values and are able to make sense of them in some more common standards-based fashion. I'm going to dive in just for a moment and talk about some of the ways that we use device identity and measurements in TCG for infrastructure purposes. We've defined a number of schemas which are used to report measurements. Right? We talk about attestation all week long, and in TCG we'll report attestations. We do that in something called integrity reports. It's both the code data from the TPM plus all the other metadata wrapped together so you can make sense of whatever it is you're reporting. Right? It's not just PCRs. It's not just the event log, but just all the metadata wrapped together. Right? We need to be able to make sense of this stuff. And so in TCG we have both halves of the equation. On the left-hand side, we have what it is that we're reporting about. And on the right-hand side, we have the reference measurements of what it is that we expect to report about. So reference manifests are those things that have a specific ID, an identity, and the reference measurement all kind of rolled up into one. And we use those as references against all the things that we actually go and measure and report on. So we can go and match those things up and say, am I getting what I expect to get? Does this meet my policy? Does it not? How do I make decisions? And I have to be able to make decisions based on some reference. If I dive down just a little bit, what you find is an integrity report is actually a combination of these things that we call snapshots. Snapshots are a moment in time, a look at some piece of data that gets measured. Whether it's the TPM itself, looking at the PCRs of the TPM, or some software components that were measured and evaluated, right? It can be any combination of hardware and software. And on the right side are what it is that I'm measuring. So IDs, where to find them, metadata about what the registry might say to help me go and evaluate which version it is. And as I go and collect a report of snapshots, I've got all my reference measurements, my reference manifest to go figure out what to go measure. And then someone later on is going to make some decision by comparing all those things that I captured against what I expected to find. So in integrity report, right, we've got one or more snapshots, could be one. We've got the quote data, we have some risk calculations, some confidence value. What was it that actually collected and reported the data? Are you basing it off something like a secure boot architecture, something like having trusted platform module report and quote the data for you, or is it kind of just most present software, a device driver, or a pre-boot unified module? Right? Based on what it is that's actually collecting the measurements, recording them, we'll have a different confidence value, different metadata associated with it, and of course the signature to kind of wrap it all together. Yes.
Sorry, what was the algorithm, or where did the algorithm come from? Standard thing?
No, it's not a standard thing at all, right? That's basic. It's not really a numerical value per se on the client, right? How does the client say, I'm 85% sure I got it right? It has no way to make that call. Instead, it's metadata that allows someone else to calculate the value. So, right. This data is from the TPM, and I can prove it. This data is from some device drivers, and I can sort of prove it. And this data is from my browser, and I've got no clue, right? And then whoever's parsing that stuff can make some assumptions and calculate their own assurance and their own confidence value based on that metadata. And then the corresponding side, we're really just talking about the provenance of the components that we're measuring. So whether, who's the trusted authority that said, yep, this is what the value that it's supposed to be. In an enterprise environment, it might be IT that actually makes the measurements of some of the values that some of the data is going to capture. But at the end of the day, it's chain of custody and source authenticity. What manufacturers vouch for which pieces of the boot process. Which software manufacturers vouch for their software components. And what we're really trying to do at the end of the day is create reference measurements for as many components of the boot process as we can, as far up the chain as we can, if that makes sense. In practice, right, these things don't really exist in the industry today. This is an initiative that we're trying to push. But we're actually working with a number of OEMs to actually go and support reference measurements, reference manifests for some of the early boot components. So there's actually good news. At the end of the day, somebody, some verifiers, can actually go and compare those two things. So based on the XML that I've just shown you, it's a relatively straightforward process to kind of just walk through and say, these are what I expect to find. I've got my reference measurements that are signed by such and such, or I've loaded them into my repository, and I trust them because I took them myself. Right? It'll go down, it'll use whatever metadata it needs, using the hash algorithms I used. And if I had to encrypt some data for confidentiality, I know CPUs based on certificates, because all the pointers are there. And so just kind of walk through the process and walk down the steps until you get to the end. And then you make a decision, this is, I like it, I don't like it, it's missing things, it's not missing things. And so we have actually a protocol that we have defined as part of the TNC specs to actually be able to go back and say, you reported some things to me, but you didn't report everything. I also need some measurements about X, Y, and Z. So you can create another reference, another snapshots or set of snapshots in the integrity report, and you get a reference manifest, and go and capture those things and send them on over. So this can be an iterative process if you decide. Right? It's not just necessarily a one-time event. So let's go back to devices again. I kind of dove into measurements a little bit already, and I kind of going back in time. You notice that software has been used quite a bit for the purpose of multi-factor authentication. Right? There's a little software module. It collects a password from the keyboard of the user. Maybe some tokens used or biometrics used over here. And at the end of the day, some software modules kind of take those things and combine them into a single credential that's used to for access control purposes. And that's kind of your most primitive device-to-device binding, right? It's not particularly robust. But it's the very, very early stages of saying, here's how I bind a couple of devices together to perform some useful function. And now, right, we're already we have a number of devices where that combination doesn't happen in software, it happens in hardware. So now I really have kind of device-to-device binding where I'm taking the results of one device and providing it to another, and it's combining with something else to make it, to actually do that combination and then make a decision. TPM 2.0 and enhanced authorization, we have the ability to do this pretty easily, right? In fact, that's one of the most valuable features that I view as part of the new device. Oh, I see some slides. So we've got this, and there are other examples of this kind of feature. And to even go a step further, right, there are a number of cases where we see devices actually linked with other devices, both whether it be cryptographically bound to have communications or physically bound. We have instances with trusted execution environment in Trust Zone where it has communications to an embedded secure element, or trusted input or trusted output paths, right? Turn off things, and you've got your dedicated paths that are open at that point. So means of putting a host infrastructure in modes where you have device-to-device binding for security purposes above and beyond some just combinations of credentials. So let's go back to attestation now. You see that there's a number of systems in place today that know how to take attributes and make attestations. Windows 8.1 clearly has the ability to use the TPM to make attestations. And there are a whole bunch of other systems in place. We must not think of it necessarily as state attestations, but TNC, whether you're using TPM or not, it's doing exactly the same thing, right? We're reporting about attributes, we're making assertions about attributes from one set of parties to another, about a combination of components, not just one. So again, the theme here is I've got a number of things that I'm looking at, a number of components that I'm looking at. Maybe there are software components, maybe there are hardware components, maybe there's combinations thereof, but I'm making assertions about the combinations of these things working together. And there are commercial products in the field that know how to take these combinations of attributes and make sense of them. And so, as an example, right, list SB 800-155. It's still a graph form, but right, it takes exactly this approach. There's only a very narrow set of things that are measured, but it's the same thing, right? I'll take some measurements of a couple of pieces and some attributes. I'll combine them together. I'll whether use a TPM or some other mechanism to actually make assertions. I'll roll that data out and provide some authority, and they're going to compare it against the reference measurements, which provide some out of band, whether it's from the manufacturer or some other trusted reference, and it's going to compare those things, just like we talked about. Reference manifests and integrity reports and snapshots. You've got the ability to check the things that you measure in this SB 800-155, the BIOS, against known references. So this isn't a new concept, and it's already being put in place, and people are already walking down the path to try to implement things just like this. Now, if I go back to the TPM or local PC infrastructure, and this is kind of a simplistic model. I already talked about having some device-to-device bindings, some based on the TPM, some based on perhaps vPro, right? You can also have some of these bindings in place. People try to use phones as tokens, whether it's trusted display or trusted input. We've been using these local trust ecosystems for some time, mostly toiling them ad hoc. But they've been there, and we've been using them in some ways. Up there, right? Typically, we're talking about binding the TPM to self-encrypted drive, right? That's just one more mechanism of doing some device-to-device binding. And there are lots of instances of this, right? The Chevy Volt, right? We talk about having 100 microcontrollers and an IP address. There's a whole bunch of devices that are bound together. Is it just one device that's communicating to the outside world, or are there many paths? I'm not sure, but I don't think it really matters. I think we've got a whole ecosystem that's built into this device. I hope hopefully it's more than just physical security that's protecting those things. And I'm pretty sure it is. The other piece that's interesting to me is that now I think that at least I recognize some of these device-to-device binaries. Someone's got to make sense of this. And we talked about having a verifier in some of the earlier slides. But at the end of the day, is some other device really going to be able to make sense of this easily? Probably not, right? If it's very simplistic data, maybe. And even then, it's probably difficult. But we're talking about some relatively sophisticated metadata. Perhaps there's several new permutations available to the users. And at the end of the day, you really need someone with the expertise to evaluate all that metadata and walk through, and hopefully there's more and more data all the time available to us. And there are people already out there who have systems that do some of those kinds of, provide some of those kinds of services. So NSTIC, or National Strategy for Trusted Identities in Cyberspace, right? They already understand things about combining user identities and device identities and being able to authenticate both of them independently and having a trust score to understand what's the quality of those things and how to combine them and be able to provide a recommendation. And Microsoft has this claims-based authentication, right? There's user claims, there's device claims. You pass things back up to some authority to validate what you actually found and measured and reported against what you expected. And based on that, you hand a token or a ticket or a certificate, whatever, that can be used for access control purposes to individual resources. And even TNC, right? It's the same thing. You've got a policy decision point there. It's collecting all kinds of data from who knows how many sources, right? As many integrity measurement verifiers as you have. And it's kind of making some decisions there, even without DPM. But these are all examples of external services, some more widely available than others, some more in their infancy than others. But external services that can take that metadata and those attestations, combine with the identity and make sense of it. If I dive into TNC just for a moment, I think this is an old diagram. And really all I want to show here is multiple collectors passing data to multiple verifiers, and on the policy decision point, taking that data and kind of making sense of it, making a decision. And just adding TPM to it, because I like colors. It's easy to say, hey, I have any combination of hardware and software assertions and combine them all together. And at the end of the day, I'm still going to make a decision over here on the policy decision point. And it just one more set of data that I can evaluate and combine in my decision. In the infrastructure work group in TCG, we've actually done quite a bit of work on integrity management problem. So some of these slides are a little bit gory in detail, but really the part that's of value is there's a creation and a source authenticity portion where somebody has to make some claims and say, I can stand up and tell you that I know the source of this content and this is what I expect it to be. And whether it's a certificate or a signature or something, some electronic piece of data that I can use to verify, it actually creates the data and makes it available for future use. And we have a policy management phase where, okay, I have all these pieces, and based on if it's past Tuesday or not, I'll choose before Tuesday I'll have these options, and after Tuesday I've got these other sets of options. People have to go and upgrade and go and get remediated. But I can take policies and apply them to the integrity management data that I harvested. And then the verifier will take those policies, take that integrity data that's actually measured at the endpoints, at the devices, and it'll make sense of this and make some kind of decision. And in the TNC case, right, all we're really doing is saying, hey, I've got my measurements. If I'm adding TPM to it, that's one more piece of data that's input from the left side, and it's one more set of reference manifests and policies coming down the right side. It's one more set of data that I can use to make a decision. There's this concept of a collaboration-oriented architecture, and it's really, computer systems that are designed to collaborate with others, where the target systems are under control of the operators. So kind of the same model as the Internet of Things, right, where I have an incentive to go and communicate with folks who I don't necessarily know and trust. And they've talked about some of their goals. And if you look at the list, right, identity authentication, updates, remediation services, device integrity, communication, right, it's all the same stuff. They still need to be able to know the device is in a particular state. They still need to be able to identify the device. They still need to know what capabilities it has so that they can make sense of the data that's recorded and how much to trust it, what kind of data is available. And then based on the identity, they can have a secure communication for either the upload of that data or if there's some command and control on the way back down to go update or go make these configuration changes. So we insert that security into the path, the communication path. And to me, there's this one special called 800-164 that's really good. And the part of it that I really look at is its definitions of roots of trust. People talk about roots of trust all day and yesterday. And usually they define three of them, right? Measurement, storage, and reporting. And this publication's done a really good job of actually breaking it out a little bit more granularly so that it doesn't kind of munge together some of those roots of trust. In TCG speak, sometimes hey, we got these platform configuration registers, yes, root of trust for storage. Oh, we have these keys over here that we use for the hierarchy. That's root of trust for storage. Like, yeah, they're both storing things, but they're doing it for different purposes. And that specification actually helps provide kind of orthogonal roots of trust. Maybe you're not going to use all of them on every platform, but when you are using them, you know what they're for, kind of how to depend on them in a more straightforward fashion, at least more straightforward for me. So if we go back to our little picture of kind of these combined trusted ecosystems, and I've got my little local trusted ecosystem, and I recognize that at the end of the day, I'm going to probably be communicating to some remote services. And as we talked about before, those remote services are going to have to depend on third parties. Maybe they're trusted third parties, maybe they're internal, in-house third parties, but some services are going to have to exist to make sense of the identities that we have and the capabilities that we have that provide information about device integrity and provide a path for update remediation. So it's, we had examples of some of these things today, but the point that I'm making and what I'd like what I hope will happen is that these services will become more mainstream as the standards are put in place for device identity, device integrity, and we'll all end up kind of relying upon these services much more than we imagine today. Hopefully they're all hidden so nobody actually sees it when they're actually using their devices. For Internet of Things where there are no users, again, it'll still be hidden. They don't have to think about it. But the relying parties, the services that we communicate with, those resources that we want to access, they'll rely on these kinds of services to make decisions for them on a more prevalent basis. Questions? Steve?
So how do you see this working across organizational boundaries?
So that's great. A number of these services, so organizations within their boundaries probably have their own proprietary implementations and passive. And so what I do is there are a number of standards that are in process today to try to standardize those kinds of communications, the device identities which we talked about, and the process of being able to work with services. So the process to do this is being standardized. What's not the hard part about your question, I think, is really how does one enterprise make its data available for use across enterprise? How do we do collaboration? And I think that at the end of the day, an organization that wants to have collaboration across amongst enterprises is going to have to make some set of data available to these services to be able to make those decisions, or provide these capabilities for each enterprise to make assertions on behalf of their own population provided back. So I think the answer is really standards, right? That's the only thing that make this work.
It seems to me as though antivirus companies would be the ideal people to do this device integrity analysis when you're doing cross-organizational thing. You need some sort of trusted third party. Do you know of any AV companies that seem to be interested in doing that?
I'm not. I think it's a good point. It's a fair point. I'm not aware of any AV companies that are doing this yet.
So Greg, I might just add a comment, which is, I think one of the things that makes it possible is that that capability, pick any specific capability, is going to have some form of a standards level assertion. And so think of it not too differently than if I want to get a PIV credential, I have to, for a personal identity, do these 6 things, whatever they are, it's unimportant. But I have to be a certified issuer of a PIV identity, and what I do is stand up behind a liability that says, I did those 6 things. And so ultimately, the capability which is articulated by device integrity is going to have to be tied back to a business process record, whether written in a logbook or more ideally an electronic form that will assert that the business process necessary to do that was actually done. And then if for something breaks and we go back and say, well, you said you had an encrypting drive, but it wasn't turned on, we want to go back and I sue you. You want to be able to prove to me that you went through that process, but the process broke, so it wasn't your fault. But if you assert you went through that process and you didn't, and you specifically fooled the system, then you end up with liability in that process.
Yeah, we actually have some standards from the TNC work group called federated TNC for conveying these sorts of assertions in SAML. Assertions about device identity, user identity, and device integrity. SAML being one of the most widely used federated identity issuers. But the thing that you're pointing to there, which is the ability to tie it back to a commonly understood framework of what a particular level of device identity constitutes within a community of interest. That's an area where we are currently exploring, let's say, because otherwise you're just saying, this device has, what I call level 4, integrity, and somebody else says, well, what the heck does that mean? What does that mean? You did to figure out that it had level 4 integrity. You need to be able to have a common framework, sort of like NIST Special Publication 800-63, is it?
Right.
Where you have different levels of trust or assurance in identity. You need to have something similar with integrity.
The human identity space has figured this problem out.
Yep.
The really good news is that devices have many fewer privacy concerns about their attributes than humans.
Yep.
And so in some ways, this should be an easier to solve problem around my medical records. Oh God, you can't have my medical records, where a device really doesn't care if you have my integrity measurements, right? And so my point is just, I think the reference model is the human identity model, but I think it's a dramatically, an order of magnitude simpler problem because you don't have all the vagaries of personal opinions about your attributes.
I'm sorry, Craig, to extend this one more round, but I'll just point out that if all one conveys are the integrity measurements for the device, that's only a subset of the picture as to whether the device is securely configured. And if I convey the integrity measurements and the rest to the other organization, and I expect them to know whether that is or is not a secure configuration, it's asking a lot in terms of interoperability. The approach that's been used with identity is to establish certain standard levels, and then each organization is responsible for mapping their own enrollment process, credentialing process, to those core levels. So I think it's, from an integrity perspective, probably more promising to do that than to convey all of the details about the device.
Makes sense.
Open issue.
This morning, when Joseph Allen was talking about, what he's calling trusted aggregation point of tap, I thought he was talking about exactly this kind of thing, but I'm not quite sure that we made it that far yet. But I think it's the exact same concepts. Anybody else?